Hello everyone, myself Akshita from Sri Venkateshwara College of Engineering. Today I am here to explain the topic about the catalog of design pattern. Let's move into contents. Contents: Introduction, essential element of design pattern, catalog of design pattern, need of design pattern, and conclusion. Let's look into introduction. The term design pattern is used in object-oriented terminology to perform the task such as defining the objects, classes, interfaces, hierarchy, and factoring them into classes with relationships. Once all these steps are considered as a pattern, they can reuse them by applying them to several common problems. A design pattern can be considered as a reusable solution for the commonly occurring problems in software design. A design pattern is not a finished design. Rather, it is a template to solve the problem in many different solutions. Now, let's look into essential element of design pattern. There are four essential elements of a design pattern. They are as follows. Pattern name. It is a unique name that describes a design problem. Pattern name, being concise and meaningful, improves communication among developers and helps to design patterns at higher levels of abstraction. Problem. It states the problem and its context, such as how to represent the algorithm as objects. It ensures when the pattern is applicable and what conditions should be met before the pattern is used. Solution. It provides a description of elements that makes the design pattern, such as their responsibility, relationship, and collaboration. The solution gives a generic arrangement of classes and objects to solve a problem. Consequences. As the name implies, this highlights the result, pros and cons of applying the patterns, etc. It describes the impacts on the system's portability, extensibility. They also determine the cost and evaluate design alternatives of pattern, language, and implementation issues. Now, the catalog of design patterns. The design patterns are organized into a form of a catalog. The intent specify what the design pattern does. Some of the patterns with their names and intents are as follows. Abstract factory. It indicates what factory is to be initiated, provides an interface to create families of objects that is related or dependent without any specification of their concrete classes. Adapter. It adapts or converts an interface of a class into another one according to the client expectation and hence overcomes the problem of incompatible interfaces, thereby enabling the classes to work together. Bridge. It separates abstraction from its implementation to make them independent. Builder. It separates the complex objects constructions from their representation in order to create different representation with the same construction process. Chain of responsibility. It enables the handling of command objects by passing them to create by using the logic present in the processing of objects. Composite. It represents the objects in a tree structure where each object represents the same interface. This enables client to treat individual objects and their compositions uniformly. Decorator. It adds additional functionality to a class at runtime. This enables flexibility to subclass for adding functionality. Facade. It creates a simplified or unified interface of existing interfaces in the subsystems so as to handle common tasks easily. Factory method. It focuses on objects, creation of specific implementation. Lets the subclass decide as to which class to be initiated. Flyweight. It performs sharing of common objects properties by a large number of objects To save space. Interpreter. It deals with the implementation of a specified computer language that solves the problems. It interprets sentences in language by representing the grammar of language along the interpreter. Iterator. It enables sequential aggregate objects elements by hiding their underlying representations. Mediator. It provides a unified interface to a set of interfaces in a subsystem. It provides loose coupling, which enable object to refer to each explicitly and also varies object's interaction independently. Observer. Whenever an object changes its state, it raises an event that notifies other objects and updates them automatically. This defines a one-to-many dependency between the objects. Prototype. Here, prototypically, instant determine the type of objects to be created. Further, new objects are created by cloning this prototype. Proxy. It provides an illusion by applying placeholder to other objects in order to have control over it. Singleton. It provides restrictions on initiating a class to a single object and also makes it globally accessible. State. It permits an alteration in the object's behavior with alteration in its state that it allows to change at runtime. Strategy. It defines the family of algorithms and the selection based upon the clients. These are all the catalog of design patterns. Now, let's look into need of design pattern. There are different needs of design pattern. First, it enables efficient communication between designers, solves an issue just by referring to pattern name, improves code readability for coders, reduce the time to find the solution by reusing tested and proven development paradigms, reduce the time for coders, introduces additional levels of indirection to achieve flexibility. Now, conclusion. The design patterns catalog offers a vital toolkit for building scalable, maintainable, and adaptable software systems. By applying these patterns, developers can tackle complex challenges with established effective solutions. Familiarity with this catalog thus enhances developers' abilities to architect robust applications, enabling them to avoid common pitfalls and leverage proven modular solutions. Ultimately, design patterns support the production of high-quality software and are an essential component of a developer's skill set. So this is all about the catalog of design pattern. Thank you.